All right, now that we've got it in some form over here, we've got ourselves, it looks like it's getting uglier and uglier. Well, it's just going to get worse, actually. So let's take a look at what's actually happening on this ring. Now, when I look at the electric field that's being created at point P, it's kind of an interesting thing. So if we look at that little segment, ds, it's creating an electric field, and it's on an angle on the sides of that triangle along the hypotenuse. So if I trace it back, the electric field created at point P, isn't it going to be some arrow that kind of goes up like that? And that's the electric field, a little piece of dE that's being created by that particular thing. All right, now, if I were to go to the other side and then get a little segment ds on this side, isn't it on the opposite side of this one? So if I draw a line and follow that up through point P, it's going to create an electric field as well. But this one, dot, 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 is going to end up going off on some line. We'll call it little dE for that one. Now, if I did this one here, it would be creating this, this, this. All right, so as I walk myself around the ring, isn't there always going to be one that shoots out, like in the direction that's kind of like along the hypotenuse of the triangle formed as it goes around the ring? This reminds me of Native American plains people that used to live in teepees. All right, so at the top of the teepee, they used to make the sticks cross like this. So if you looked at the sticks as they came out of the teepee, they're actually going off on some type of angle. All right, now, let's take a look at one of these angles. So if we take a look at, say, this vector as it goes out this way, all right, and when we're looking at that particular vector, it has some little dE to it, like that. All right, now we also look, the triangle itself has an angle to it. So in the very top angle up in here, let's just call that angle theta. So as we look at this particular dE, dotty, 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 like this, it actually goes up at some angle which is actually equal to the one of the triangle, like so. So we're creating a couple electric fields. We've got the electric field that's perpendicular to the z-axis right here. And we also have an electric field here that's parallel to it, like that. All right, now, let's take a look at the one on the opposite side. Isn't there also one on the opposite side of the TP like this? We'll call it DE. Dotty, 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 like this. And it comes across here. Doesn't it also have an electric field created that's perpendicular? Ooh, that's not supposed to be a T. That's a perpendicular side. All right, and it goes to the right. This one also creates a little E parallel as it goes up like this. And the angle in here is theta. All right, now an interesting thing's happening. If we look here, there's one that goes to the left, going for this side, and isn't there one going to the right, going that way? So for every one of those little TP balls that come out, one's going to the left and one's going to the right. What happens in the x-axis direction as we go across? Well, isn't that one and that one always going to negate each other? All right, now let's take a look at the parallel ones. This one goes up and this one goes up. They don't negate each other. Those are the ones that are creating the electric field. All right, now if we look at the triangle, what trig function are we going to use when we have the side that's next to the angle, also known as the adjacent? I smell cosine. So let's take a look at this. So we end up with the hypotenuse, E cosine of the angle, and that's going to give us the electric field from that side. And on this side also, dE cosine of the angle there. Those are the contributors to the electric field itself. So the only thing I care about are the ones that are going upward, the ones that are dE cosine theta, because the ones going in the x direction, left and right, are always going to negate each other. So the total electric field only comes from the contributions of the parts that are going upward.